In 12.3 we're looking at inscribed angles, and we want to know about the measures of those inscribed angles and how they relate to the arc that they intercept. So first of all, an inscribed angle would be any angle where we have the vertex on the circle and then it's crossing through the circle and then it's going to cut off an arc on the other side. That arc that it cuts off will be called the intercepted arc. We'll also have chords of the circle that are intersecting there. Now the theorem that we have is that this angle right here, the inscribed angle, is always going to be half of the measure of this arc over here. Now remember, we define the arc measure, by the central angle measure, which we can see here. So those two have to be the same. So even if I change them, they're going to be the same. Notice that this inscribed angle, since it's further away but going to the same points on the circle, has to be smaller than that, and it just so happens that it's half of that size. No matter where I go, notice the angle size actually stays the same. Even though the chord lengths are changing here, as I go around, it's not changing the measure of my arc angle here. The only way to change the measure of that would be to change my central angle. But if I change my central angle to a different value, then it's still going to be half the size of either the central angle or the arc that it intercepts. So we'll use this. Sometimes these problems can look a little complicated, but what we'll do is we'll look where these different measures are. So the measure of arc AB, and we'll just pay attention where that is. That goes right here, is 140. We can look at BC, which is right here, and that is 100 degrees. And we also know that AD and DC are congruent. Now notice this is not drawn to scale, otherwise we would see, because this one clearly looks bigger, but they're telling us that they are the same. So now we want to find the measures of angles 1, 2, and 3, and maybe we can also find some other angles. I'm actually going to start with 4 and 5. Now let's start with angle 4 here. And what we want to do, notice the corner is on the circle, and let's look at where these sides are going. This side over here is actually passing through A and passing through B, which means it's intercepting the arc 140. So the measure of angle 4 has to be half of the measure of arc AB, which means half of 140, or 70 degrees. I could also look at the measure of angle 5 here. If I look at angle 5, I look at the sides of that angle 5, it's going to B, and it's going down to C. Notice it's cutting off the arc 100. So the measure of angle 5 be equal to half of the arc that it's cutting off, BC, which has a measure of 100, and so the measure of angle 5 would be 50. If I look at the measure of angle 3, notice the sides of angle 3 are also going to B and C, which means it's cutting off the same arc, and so the measure of angle 3 will also be 50. It's the same as angle 5. For the next part of this, I'm going to need a little more information. We do know this is a circle, so going around should be 360 degrees. So let's look at what we've already used. If we take away that 140 plus 100 that we've already used, that'll be 240, leaving us with 120 degrees. Now, since these two arcs are marked as congruent, we know that each one is 60 degrees. Now we use that to find the remaining angles 1 and 2. Let's look first at the measure of angle 1. Measure of angle 1 is here at B. It's going through D and A. That means it's cutting off this arc right here of 60. So it's going to be half of 60, which gives us 30. The measure of angle 2 is cutting off DC here, which is across from this 60. So the measure of angle 2 is also 30 degrees. The next theorem looks at what happens when we have two inscribed angles cutting off the same arc. As we can see, as we move this around, it doesn't change the angle measure of this. So if I have two inscribed angles cutting off the same arc, they're going to have the same measure. This would also be true if we have two different arcs, but the two arcs have the same measure, then their inscribed angles will also be congruent. The next theorem looks at what happens when we're dealing with a diameter. So if we have a diameter and an inscribed angle, then that has to be a 90-degree angle. The reason this works is because the arc that it's cutting off here is half the circle, 180 degrees. So no matter where I move this, it's cutting off a 180-degree arc, half of that would be 90, so this will always be perpendicular. This can be used in a problem like this, where we're asked to find the measures of angles 1 and 2. Here we're given algebraic measures, but we do know, based on their location, since E would have to be a right angle, since AD is a diameter, then angles 1 and 2 would be complementary angles. Those are going to add up to 180, so the measure of angle 1 plus the measure of angle 2, or 12x minus 8, plus 3x plus 8, have to equal 90 degrees. The minus 8 and plus 8 will cancel out, giving us 15x equals 90, or x equals 6. Now we were asked to find the measures of angle 1 and 2, so we should go back and actually plug that value in. Plugging into angle 1, that will give us 12 times 6, which is 72 minus 8, which is 64 degrees. And the measure of angle 2, if we plug the 6 in, that will give us 18 plus 8, which gives us 26. Notice we add those together, they do give us 90 degrees, so that's another way to check it. In angles 3 and 4, we have to look for a little bit more information that's given to us in this problem. Notice they tell us that arc AB is congruent to arc BD. So if we're cutting off congruent arcs, that means the chords are also congruent, so AB congruent to BD. If there's a 90-degree angle and these are congruent, then that means both 3 and 4 have to be 45-degree angles. The last theorem is dealing with any quadrilateral inside of a circle. That quadrilateral has to have opposite angles, so if I look at angle B with angle D, they have to add up to 180 degrees. And also looking at angle A and angle C, they would also add up to 180 degrees. Now we can see that because this arc, this red one, is the intercepted arc for angle B. For angle D, the intercepted arc would be ABC. Notice those two arcs add together to give you 360 degrees. So if two arcs, they have half the measure of their intersected arcs, if we add them together, they would have to add up to 180. Okay, so in the last one, they give us the measure of angle B as 80 degrees, and they give us the measure of angle C as 40 degrees, and they ask for the angles A and D. Well, since A is across from C, then we know that the measure of angle A would have to be supplementary to that, leaving us with 140 degrees. The measure of angle D, it's across from angle B here, so they also add up to 180, so that would leave us with 100 degrees.